sign, it becomes the alternative hypothesis. So H1 comes from the claim, and it says what? Mu is greater than 54. Our null hypothesis comes from the counterclaim, and we make that into an equal sign, just like we did in the last case. So instead of saying mu less than or equal, we just say mu equal 54. This came from the claim, H1 came from the claim, H0 comes from the counterclaim. Now look at the inequality sign for H1. Is the inequality sign for H1 a greater than sign or a less than sign? It's the same as the inequality sign from the claim. So last time we had a less than sign in problem 9. Now in problem 10, the inequality sign for the claim, hence the inequality sign for H1, is a greater than sign. Greater than signs lead to right-tailed tests. So this is now right-tailed. Right-tailed means when we get to step 4, our p-value will be 1 minus the table value, not the table value. So, now we move to step 2. Of course, step 2 is just give the given significance level. This is all, I'm going to erase, this is all given in the solution key. So, step 2, our given significance level, we're testing this claim that the mean lifetime of a single battery is greater than 54 hours. This is going to be tested at a significance level of 0.01. That's like 99% confidence. Now to do step 3, we need to use the given, what's given first. What's given here is we took a sample of 400, so N is 400, we took a sample of 400 manufactured batteries. From that sample of 400 manufactured batteries, we measured the lifetime of each one, and we came up with a sample mean lifetime for those 400, which is given to be what? 55.2 hours. So the mean lifetime of the 400 randomly selected batteries was 55.2 hours. This is all given. And the standard deviation is given to be 8 hours. Now, we can use that to plug into the test statistic that's on page 520. So if we look on page 520 of the cheat sheet, what we see is the test statistic looking for page 520 here. The test statistic given in step 3 on page 520 or 521 is given to be Z0, it's a Z-score again, but now we write it as X bar minus mu naught being what? 54 hours, that came from the claim. Is that right? Yeah. And that's all divided by sigma over the square root of n. It might be easier to write this as X bar minus mu naught in parentheses times, take the bottom fraction and flip it. So when you divide a fraction by a fraction, it's easier to write it as multiply by the bottom fraction, but flip it. So it's easier to write this as X bar minus mu naught times the square root of n divided by sigma. And that's how I wrote it in the solution key. So now I just have to plug the given statistics in there and get the test statistic. When you do that, you get Z0 is equal to 55.2 minus 54 times the square root of 400, all divided by the standard deviation, which is 8. If you plug all that into your calculator correctly, what comes out is 3.0. So our test statistic is 3.0 here. If you can't see that, 3.0, it's all written in the solution key. So that's our Z0 from step 3. We take our given sample statistics, plug into the test statistic Z0, and we get 3.0 for our test statistic Z0. Now move to step 4. The only thing different is the test statistic in step 3. Everything else is the same as before. For step 4, what do? we first use our test statistic and table 5 to look up a table value for that z-score. So we're going to use 3.00 as our z-score. Go to table 5 for positive z-scores. And when you go to table 5, look for positive z-score 3.0. You're first going to find 3.0 in the left column, and then you're going to look for 0.0 in the right-hand top row, and get the table value for 3.00. And that table value comes out to be 0.9987. So the table value for z-score 3.0 in table 5 came out to be 0.9987. Now, since we have a right-tailed test, when you have a right-tailed test, the p-value is 1 minus the table value. When it's a left-tailed test, the p-value is the table value. Remember, we have a right-tailed test in this case. So since we're right-tailed, the p-value is 1 minus 0.9987. So our p-value comes out here to be 0.0013. So that's the p-value for this test. And this is all written. So we do 1 minus the table value because we're right-tailed, and our p-value is 0.0013. All this is in the solution key. Now, same step 5 as before. Our step 5, it says in step 5, same thing. It says that it said in the last one. On page 521 it says, if your p-value was less than the given significance level, and our significance level was 0.01. Our p-value, so our significance level was 0.01, our p-value came to be 0.0013. Notice our p-value is smaller than our significance level in this example. So since the p-value is less than alpha, it says in step 5 that we reject H0. So this time we are rejecting H0 because the p-value is less than alpha. And so now when you go to step 6 and state your final conclusion, you look at that flowchart, and what that flowchart says is you answer no to the first question, that the claim does not contain the condition of equality. You go to the second question, it says, did you reject H0? And this time we answer yes to the second question. We do reject H0. So that means that the sample data does support the claim. So there is sufficient evidence in this case. At a significance level of alpha equals 0.01 to support the claim. The claim that the mean lifetime of a single battery, of all the batteries, is greater than 54 hours. All right, I'm not going to ask about the type 1 and type 2 errors here because we don't have time. So you can skip the part about type 1 and type 2 errors here. Just give the final conclusion about the claim in both problems 9 and 10. Also, I don't have time really to go over problem 5 about expected value. Like I said, if you want to do the extra credit problem, you can read the example problems worked out in the notes from chapter 16 at the end, which cover that same topic. And the solution to problem 5 is on the solution key. So you can find the solution to problem 5 written in the solution key to the test, to the practice test for test 3. You can also find other example problems of that type at the end of the chapter 16 notes. I'm going to, for time's sake, not do that problem just because we don't have time to do it today, and it is an extra credit problem. So if you want to prepare for that extra credit problem, problem 5 from the practice test, then look at the solution key to the practice test and look up the section of the supplemental notes about expected value in those worked out example problems. So this is going to conclude going over the practice test. Like I said, if you have questions over this or anything else, I will be on the chat from 8 to 9, Monday through Thursday. Monday, August 6th to Thursday, August 9th, from 8 to 9 on the chat of eCourse. You can ask any questions over this video or the video over hypothesis testing or any other questions pertaining to Test 3, and I'll do the best I can to answer your questions on the chat anytime from 8 to 9, either Monday, August 6th, up to Thursday, August 9th, from 8 to 9 p.m. on the chat. So hopefully this helps to show you how to do all the different types of problems. The test will be very similar to the practice test, problem by problem. I'm going to give the same exact types of problems, they just won't be exactly the same as the practice test. But they'll be similar to the problems on the practice test. So, best of luck, and if you have any questions, get on the chat and ask questions sometime next week between 8 and 9. All right, good luck on the test. Thank you. Bye.